Hi, everybody. Welcome to video 3 in our series for the Sustainability Teachers Academy online programming. In this video, I'm here talking with student worker slash intern slash future sustainability superhero, Julia.
Hi, everybody.
And we're going to be discussing something that's crucial to the understanding of sustainability, which is wicked problems. We're going to talk about what they are, what wicked problems are, how they relate to sustainability, and eventually we'll talk about some of the tools that you might need in order to address sustainability problems.
So in the last presentation, we talked about how sustainability problems usually have a central problem that's being exacerbated by social and cultural causes, environmental causes, and economic causes that are all interrelated together. And these are also kind of the three pillars that we talked about earlier. So that's a theme that's going to continue through the rest of your videos and the workshop itself.
Another thing that's characteristic about sustainability problems is it's not just that they're more complex problems, it's that they're a totally different class of problems. And what you'll see from this video is that we'll make a comparison between the typical kind of problem that we face day to day and sustainability problems, which are, as I said, a totally different class.
So we call these problems wicked problems.
We're going to compare two types of human-caused environmental problems, ozone depletion and climate change. And what you're going to see is that ozone depletion falls into a category called tame problems. These are your run-of-the-mill, simple, easy-to-solve problems that we encounter on a regular basis.
And climate change falls into the category of wicked problems, which are basically the opposite of tame problems, where there's complexity and urgency and all this kind of interconnectedness involved in them that makes them a little bit trickier to solve.
And so when you're looking at sustainability problems, you have to use a different skill set in order to address and to solve those problems. You can't use the same simple problem-solving techniques that you would for a tame problem like ozone depletion. One of the ways that we can show the differences between tame problems and wicked problems is by asking simple questions and seeing what kinds of complexity or interrelatedness there is when we try to answer those simple questions. So let's ask, for example, how does ozone depletion affect your health? What you'll find is that there's a very direct connection between ozone depletion and its causes and the impacts that that has on your health. So for example, in this diagram, we see that increased ozone-depleting substances cause a depletion in the ozone layer, and that results in increased exposure to ultraviolet rays. That, in turn, has major consequences for human health. It causes sunburn, it can cause eye damage, and even skin cancer.
But when we ask that same question for climate change, the diagram looks a little bit different. As you can see, there's lots of different causes and lots of different effects of these things. So for example, here in Phoenix, we have increased respiratory illnesses due to rising temperatures. During the summer, it's really hot here, so people will drive in their cars more, which means more cars on the road, which means more emissions and it gets hotter because of the urban heat island effect. And so those emissions will cause more respiratory illnesses. And that's just one train of problems that happens whenever we're talking about climate change and human health.
We're going to present to you 6 different ways in which tame problems and wicked problems are different. And for each of these different categories, we're going to show you how ozone depletion compares to climate change. So our first step is to look at how the problem is defined. You'll see that there's a major difference between the way in which you can define tame problems versus wicked problems. When it comes to ozone depletion, which is a tame problem, we see that we can clearly define what the problem is. It's easy to understand. Most people can get the general idea about that problem very easily. And when we talk to scientists and other experts, we find that there's general agreement not only about what the problem is, but also how to solve it. So think about ozone depletion. We know what that is. The definition is very straightforward. It's a steady decline in the total of Earth's stratospheric ozone, and it results in a large seasonal decrease in ozone over the Earth's polar regions. We can look at ozone concentrations in the atmosphere over decades, and we can see that there's a large dip in the ozone thickness, and then in polar regions especially, over the past 50 years.
So climate change, on the other hand, is a little bit more difficult to define. So whenever you say, well, what is climate change? It can be a lot of different things. It can mean a lot of different things to different people. And like we saw on that chart, there's many different causes and many different effects of it. So it's also can be too complex to fully understand. So fully understanding climate change means that you have to fully understand how climate is changing around the entire globe, which can be really difficult to do. And it's also a pretty controversial topic. So whereas ozone depletion, when you talk to experts, they're all in consensus of what's happening with climate change. There's still some people that say it is happening or not happening, or it's happening in some certain ways and people think it's happening in other ways. So there's not one consensus about what's happening. There's not one consensus about what's happening in the world. So one part of the definition of climate change is that there are rising temperatures, which you can see on the NASA graph depicted on the left. But then other parts of climate change may have to do with changing weather patterns, higher temperatures and more heat waves, more droughts and wildfires, rising sea levels, damaged corals, and other parts of the diagram on your right. In order to understand the full picture of climate change, you have to understand this information from many different sources. And so to get that full picture, scientists from everywhere have to collaborate, and that often doesn't happen because it's difficult to collaborate across disciplines and fields.
Another way in which tame problems and wicked problems are different has to do with the factors that are causing them. When it comes to ozone depletion, for example, and other tame problems, you see that there's generally a single root cause, and that makes it easy to understand the relationship between cause and effect. There's often a direct relationship between the cause that there's often a direct relationship between the single root cause and then the effects that you're witnessing on the other end. When it comes to ozone depletion, we know exactly what's causing it. These substances that were once used as refrigerants or aerosols, CFCs, made their way into the upper atmosphere. They broke down ozone molecules faster than they could be replaced, and that resulted in an overall thinning of the ozone layer and also these large holes in the ozone layer that appeared above the north and south poles. And this can actually be tested in the lab, so we knew that this was going to happen before we actually started to observe the effects in the environment.
So the causes of climate change, on the other hand, are very different. They're usually multiple and interrelated and interdependent, which means they all affect each other, and there's often more than one possible explanation for what's happening. You probably know that the primary cause of climate change is carbon dioxide. As shown by this graph, there is a direct correlation between increased carbon dioxide in our atmosphere and increased temperatures of our planet. But carbon dioxide isn't the only greenhouse gas. As you can see in this graph represents at least 5 other greenhouse gases that are emitted by humans. So black carbon, which is the aerosols from any burning of carbon material, are also causing climate change. So it usually, you can think of it in the form of soot, so it gets into the atmosphere and then it actually interferes with the albedo effect. This actually darkens the surface of the planet, which actually means that more solar radiation is absorbed instead of reflected, which then increases the surface temperatures of the Earth. So additionally, 1/3 of the excess CO2 in the atmosphere since 1750 has come from deforestation. And that also means because there are less forests, that means the Earth has a reduced capacity to sequester carbon. So finally, we're going to talk about how shrinking ice caps are related to climate change. So this problem is actually more of a feedback loop, which means that these ice caps are shrinking because of rising temperatures, but that also means that there's less of this white ice surface area that can reflect the solar radiation back away from the planet. So because there's less of the white space, it means that there's more kind of darker ocean surfaces or land surfaces that then absorb solar radiation, which means that temperatures continue to increase on the surface of the planet, which means that the ice caps are melting even faster.
Another way in which tame problems and wicked problems are different has to do with how we can measure the success of interventions to try to improve things. So when it comes to ozone depletion, we could determine an objective measure of success, and once that goal gets reached, then we can stop the intervention that we implemented. For example, we can objectively measure the success of our interventions to halt ozone depletion by measuring the thickness of the ozone layer around the planet and monitoring the large ozone holes in the polar regions to see that they're shrinking. We already know from data that was provided by NASA scientists that atmospheric ozone levels are on track to be completely repaired by the year 2040. So in other words, we have an objective measure of success that the ozone thickness and ozone holes will return to their normal state, and we know that our intervention is working.
So climate change, on the other hand, is not as simple. There's actually multiple criteria for success. So even though there might be one cause and another solution you identify, there's probably a lot more. And then there's always room for improvement. So even if you may find a solution to something, it may not continue to work because the problems are changing. So that means that you have to keep innovating and keep finding new ways to solve problems.
Tame problems have another benefit over wicked problems in that when you test a possible solution, it's easy to do, and the solutions can be derived from trial and error. Let's take a look at how this impacts ozone depletion. We identified the cause of ozone depletion back in the 1970s, and by the 1980s, we had reduced the global use of the chemicals that were depleting ozone. What we can now see is that the ozone layer is approaching a repaired state, and data that's been available from NASA scientists indicates that the ozone layer should be completely repaired in around the year 2040.
When it comes to climate change, testing the solutions is more difficult. Usually there are multiple interrelated and interdependent causes because climate change is happening in different ways around the world, and it's difficult to establish effectiveness of possible solutions because we don't have those same cause and effect relationships as we do with tame problems. For example, this graph shows a comparison between CO2 emissions and CO2 absorption. So if we focus only on reducing CO2 emissions from cars or factories or other things without then planting more trees or providing more areas for carbon to be absorbed, you don't have a full picture of what's going on. Additionally, different countries emit different amounts of CO2 emissions. If one country continues to emit more CO2, but another country continues to emit less CO2, they may offset each other. This also happens with industry. So even if industrial processes become cleaner with more regulations and more commitments to it, if demands for power generation go up, these will also offset each other as well.
When it comes to tame problems, the outcome of the intervention is pretty straightforward. Either the intervention worked or it didn't. For ozone depletion, reducing the production and emission of CFCs actually allowed the ozone layer to begin to repair.
Climate change is different. The intervention may work in some ways but fail in others, and this also is attributed to how climate change is happening in different ways around the world. And wicked problems often have unintended consequences, which means that whenever you try to solve one part of a problem, it may affect other parts of the problem in ways that you didn't plan. One example of this is over the past 50 years, our carbon dioxide emission has increased as industry has increased, which has allowed us to be more productive. This has also resulted in an increase in GDP. So if we have strategies to dramatically reduce CO2, how will this affect our GDP? Let's look at 3 examples of seemingly sustainable solutions that actually have some challenges. Example 1 is China's increased demand for solar panels. Those solar panels are a great alternative for energy that also increases the demand on rare earth materials, which come from mining. In the case of increasing the amount of dams for hydropower, this may be also a good alternative for energy, but it can greatly damage ecosystems. And in the case of carbon taxes in the United States, this may seem like a good legislative solution for the entire country, when in reality it may be difficult for some states to implement this compared to others.
Other characteristics of tame problems is that they're commonplace. You can see the same problems or same kinds of problems all across the globe. They're also self-contained, so once you've solved that problem, you're done.
Climate change is the opposite. Each wicked problem is unique, which means that the causes and solutions are very different from each other. And every problem is a symptom of another problem because they're all interrelated and interconnected. So as you can see, climate change is messy, and all of these impacts are interrelated, and finding one solution for everything is impossible.
This chart provides you with a summary of these differences that we've covered in this video. Tame problems, as you can see, are easy to understand and easy to solve.
Wicked problems, on the other hand, are more complex, which makes them extremely difficult to solve, and there's actually never one solution.
Thanks for watching our video on wicked problems. We hope you learned a little bit more about sustainability and about how to think about sustainability problems.